How does ocean acidification affect coral bleaching? Have you ever wondered how the chemistry of our oceans impacts the vibrant coral reefs? Today, we are going to look at the connection between ocean acidification and coral bleaching. Ocean acidification happens when the ocean absorbs excess carbon dioxide from the atmosphere. This process causes the seawater to become more acidic, which means it has a lower pH. This change in the ocean's chemistry reduces the availability of carbonate ions. These ions are crucial for corals to build and maintain their calcium carbonate skeletons. As the acidity of the water increases, corals find it harder to thicken and strengthen their skeletons. Weaker skeletons make corals more vulnerable to damage and breakage. Now, let's talk about coral bleaching. Coral bleaching occurs when corals are stressed, often due to elevated sea temperatures. When stressed, corals expel the symbiotic algae that live within their tissues. These algae provide corals with energy through photosynthesis and give them their vibrant colors. Without these algae, corals turn white and become more susceptible to disease and death. So, how does ocean acidification play a role in coral bleaching? First, acidification lowers the threshold at which corals bleach in response to heat stress. This means that corals are more likely to bleach when exposed to warmer waters combined with higher acidity. Additionally, high levels of carbon dioxide can directly cause bleaching by disrupting the protective mechanisms of the corals' symbiotic algae. This disruption reduces the health and productivity of these algae. Moreover, ocean acidification impairs coral calcification. This means that the growth of coral skeletons slows down, making them weaker. Weaker corals are less resilient to bleaching events. Certain species that help build reefs, like crustose coralline algae, are particularly sensitive to acidification. If these algae experience reduced growth or even dissolution, it undermines the stability of the entire reef. The combined effects of warming waters and acidification reduce the number of safe refuges for corals. Many reef areas become increasingly hostile to coral survival. This situation threatens the biodiversity and abundance of marine life that relying on coral reefs for shelter, food, and breeding grounds. For marine animals, coral bleaching and acidification mean a loss of habitat complexity and resources. This can lead to declines in fish populations and other species that depend on healthy reefs. In summary, ocean acidification intensifies coral bleaching by lowering corals' tolerance to heat stress, impairing their physiological functions, and weakening their skeletons. This dual threat jeopardizes coral reef ecosystems and the diverse marine life they support. Addressing carbon dioxide emissions is critical to reducing both ocean acidification and warming, helping to protect coral reefs and the sea animals that inhabit them.